Now we discuss important some important signals. First we start with unit step signal. What is unit step? Mathematical expression for unit step signal is 1. T is greater than 0, less than 0 is 0, at 0 is undefined. Draw for unit step is 1 T. Unit step denoted as, mathematically we can represent in this way and graphically we can represent in this way. If someone wants to draw u of minus t, for drawing u of minus t, this is very simple in this way. How it's come? U is defined between 0 to infinite and u of minus t defined between, again we perform same inversion operation as previously we discussed. Inversion operation, solve for t. By solving for t, complete expression is defined in the range of minus infinite to t. We can further draw other derivative of ut, minus t minus 1. How can we draw? Simple. T is defined in between 0 to infinite and u of minus t minus 1, put modification in the range of minus t minus 1, solve for t. 1 minus t infinite we can draw minus 1 to infinite minus infinite u of minus t minus 1. By just shifting in time scale we can draw in this way. I took one more example, somewhat typical example, useful for IES and GATE both also. We can represent any type of signal in term of ut and its derivative. How it is possible? I draw a random type of, not uniform type of signal, a random type of signal. Minus 3, minus 5, 1, 5, 2, 7, 4. We can write down expression for this given diagram. How can we write down? We took an idea. We start from minus 3 time reference and amplitude is minus 5. So first we put minus 5 amplitude, start with t location minus 3, minus of 5 ut plus 3. Expression for this. Now move on this line. Next change over on this point, minus 1. Difference in amplitude level is positive 4. From minus 5 to minus 1. Minus 5 to minus 1. It means positive 4 amount of difference. Location is u of t plus 1. Again, change over at 0 location. Difference between amplitude is -125 means 6 plus 6 at location 0 and move further. Difference between these two at location 2 and difference between two level is -12. -12. 5 to -7 is -12 at location. Now move ahead in this direction. Next change over with +7 amount at location -4. This is the complete answer for this drawing. Yeah, this signal draw. We start with -3 location, -3 location, amplitude is -5. At -1 location, change in amplitude is 4, location is -1. Again, location is 0, change in amplitude is +6. Again, location is +2, change in amplitude is -12. Change in amplitude is +7, location is 4. In this way, we can draw any type of unit step derivative. Move to next important signal. Second one is unit step sequence. We use signal for continuous time signal and sequence for discrete time signal. Mathematical expression for unit step sequence is 1. N vary from 0 to infinite, otherwise 0. Graphical representation for this: signal is start at 0 location up to infinite. Magnitude is constant throughout the length. Unit step sequence. We can draw same way as in unit step signal. We can draw u of 3 minus n. We want to draw this shifting. Un is defined between 0 to infinite. 3 minus n is defined between, by solving this we can define from 3 to 3 minus n. Solve for n. -3 this discrete signal started at -infinite location and up to 3 it is constant 1 value. By shifting we got this result. Another important signal is, third important signal is unit impulse. Unit impulse function. Unit impulse function, which is very important in GATE. Last 10 years, 3 and 4 times question come from unit impulse function. What is unit impulse function? It is also known as Dirac delta function. Unit impulse function or Dirac delta function. Mathematical expression for unit impulse function is, at 0 location, value of this unit impulse is infinite, otherwise 0. This is not complete definition of unit impulse signal. Some portion of definition is area covered by unit impulse is 1. Now it is complete definition of unit impulse function. This definition in 2006 GATE question paper. This definition come in 2006 GATE question paper as a objective. Very important definition. Area covered by impulse is always 1. Sum of the idea denoting impulses. Graphical representation of impulses at t equals to 0 location, 1 arrow. This arrow denote area covered by impulse. Graphical notation. This is ideal. This is ideal impulse. But some practicality added in by some different ideas. This impulse is ideally 0 duration. Practically some duration may be there. For example, I took duration is epsilon. If width of the impulse is 2 epsilon, height surely be 1 upon 2 epsilon. If I consider impulse as rectangular pulse, then area covered by impulse is 1. If someone consider as a triangular pulse, area covered by impulse is also 1. If I consider it may be triangular pulse, it is just idea. Ideally it is 0 duration pulse. Practically somewhat duration is attached with impulse function. If it is triangular, this much of duration, triangular pulse of this much of duration, height may be half into epsilon into x equals to half. X may be 2 by epsilon. Height of this is 2 by epsilon. It might be triangular pulse, it may be Gaussian, it may be rectangular pulse, any of type. Ideally it is a impulse of 0 duration. Practically it is somewhat duration. Duration is epsilon 10 to 0. Other properties of impulse are first scaling. What scaling says? If impulse is scaled by a amount, then if scaling by a amount, impulse is modified in this way. Magnitude covered by impulse is modified by 1 upon mod a. A may be any value. I took an example 2t. Result will be area covered by impulse is modified. Area covered by impulse is previously 1, now it is 1 by 2. 1 by 2. If scaling amount is minus 1, then this impulse is denoted as in this way. Second property, sampling. As per sampling, we write down some statement. Multiplication of signal xt with impulse will be impulse function, but strength of impulse is governed by xt at location of impulse. It means xt multiply with impulse at location t naught, result will be xt naught impulse at that location. Multiplication of signal xt with impulse will be the impulse function. It is another impulse function. Strength of impulse is governed by xt at the location of impulse. This property using for solving some specific questions. I took some example come into GATE paper and DRDO paper. Example 1, T del T. What is the value of this? T. T is a straight line passing through origin. This is multiplied with impulse. Impulse at zero location multiply with this. At a zero location, this slope has value t at zero location and impulse. T at zero location is 0, means result will be 0. At a zero location, slope t passing through origin, impulse multiply with this, result will be 0. This question come in DRDO paper 2008. Cos t del t minus pi. What will be the result of this expression? If impulse is multiplied with some signal strength is governed by impulse location. By putting this impulse location into the signal, we got cos pi del t minus pi. Cos pi is -1 del t minus pi is our final answer. Very simple question. Now to one more example. Del omega we want to convert into del f. Omega and frequency have some relation to pi f. By scaling property 1 upon 2 by f. 1 upon 2 pi del f. This is the direct relation between omega and f. We use in communication. This expression is used in communication. One more example. For 2t plus 3t square del t plus 2. For solving this expression, impulse is located at -2 location. By putting this value in this, we got strength of the impulse. 1 plus 2 minus 2 plus 3 minus 2 square del t plus 2. What is the result? By solving this, we got the result 1 minus 4 plus 12 del t plus 2. Final result for us is 9 del t plus 2. This is the final result for us. One more type of question is available to us, integration. We took two more example, minus 1 to 1, 3t square plus 1 del t dt. If we put integration before this expression, means we are calculating area covered by this expression. Area covered within this range minus 1 to 1 by this expression. In this question, impulse is located at 0 location. Means area covered by impulse is 1. First solve this expression and then put area formula. 3 0 square plus 1 del t dt. Minus infinite to infinite del t dt. Area covered by impulse at 0 location is 1. 0 is covered in this range. In this range, 0 is covered. 0 is a part of this range, means area covered by this pattern is 1. Same type of, by changing the limit, we generate second question. No difference between question 5th and 6th, but range of the question is changed. Solution of this pattern is same as previous, del t dt. But impulse is located at 0 location, or 0 is not part of the range, so answer will be 0. One more question I took. This is the last one, I think. One more question I took. Minus infinite से infinite e power minus 4t del t plus 0.3 dt. In this question, we again solve same way. Impulse is located at minus 3 minus 0.3. By putting this value in this expression, minus 4 into 0.3 del t plus 0 dt. This impulse location is covered in this range. What will be the result? Result will be we put the minus 0.3, result will be plus 1.2 e power 1.2, our answer. In this way, we solve different type of questions. Another important signal we took